Okay, this is going to be a very short video on manipulation of inequality. Specifically, all I want to know is under what condition will an inequality sign flip? Or let's say this inequality sign, when will it flip? Our common understanding is when we times negative. Correct? Let me give an example here. For those who are not familiar, let's say I have this inequality x greater than 5. Well, let's think of some numbers that you can take on. So some examples where you could have 6, or you could have 7, and so on and so forth. Now, if I were to times both by negative, you can see very clearly, okay, is it still this sign here? Is it still bigger? Well, then let me look at each of these examples. 6 will turn into negative 6, 7 will turn into negative 7, and you see that on the number line, negative 5 is here, but negative 6 and negative 7, it seems to be going further away from negative 5. Then we point in this direction. So observe that the sign has flipped. Okay, for those of you who are familiar, well, this is simple. Now there's also one more rule that I'm not sure if you have been taught this in school, but there's also one other time in which the sign would flip, and that is when you take reciprocals. What is reciprocal? Let's say I give you x, the reciprocal of that is 1 over x. So you can just think of, when I say reciprocal, you just think of 1 over whatever the original was. Okay? Or you can think of it as power minus 1, up to you. They are the same. So let us consider a interesting case, or a generic case that I would like to put forth here today. Suppose I have this inequality. Okay, what happens when I take the reciprocal of x, i.e. I take 1 over x? What do you think is going to happen? I'm going to give you the answer. So what went on here? This sign, smaller than, will turn into greater than, and you come over here. And so will the number along. Of course, we're doing reciprocal, so it's 1 over b. Okay, and likewise, the same effect on the other side. If there were an equality sign here, it will come over here. Okay, so this is just an interesting case. We would like to ask ourselves why, and is this true? Can I trust it? Well, let's try one case. So let me give you an example over here. What are some numbers that x could take? Okay, let's try to make it a whole number. I prefer that. Okay, what are some of the values x could take? Well, x could be equals to 2, 3, 5, blah, blah, blah. All the way maybe to before 10. If I were to take 1 over x, what are you going to get? So on and so forth. And these two values here, well, 1 over 1 is 1. And here, 1 over 10 is 1/10. And that's weird. How can, so if this will become 1 over x, how can 1 over x be greater than 1 if I keep this inequality sign, and yet smaller than 1 over 10? That just can't hold. A number that's greater than 1 and smaller than 1 over 10 at the same time. Not possible. So if you were to study the values that you could take, you would see that if you were to draw on a number line from 1 over 10, which is 0.1, all the way to 1, the values do indeed fit in between here. Okay, so the rule of thumb, if I have two positive numbers, you want to take 1 over everything, you are just going to take these two and switch sides after putting the 1 over everything, and these two, inequality, switch sides as well. Okay, so this is just an interesting shortcut. Now, I mentioned that a and b must be positive constants. If 0 is included in this value, now we're going to have some funny values here. And then this rule, general rule, will not apply. Okay, so this is just a special case. I'd just like to bring your attention. So it's just to know. Okay, hope you learned something today.